Last week I started the quality of service, talking about it briefly. I will talk about it and cover some slides. But then if you remember what I said in that class, I said this is a word of its own. This particular topic is a word of its own. It is difficult to do justice to this topic in one chapter. It's very difficult. But I want to believe that the reason why they just put this in CCNA is just to give an idea. People to know that there's something out there at CCNA level. So we're not going to do any configuration. It's just to explain some concepts, and then we'll leave it there. When you move to the next level, to CCNP, you're going to meet it there in details. And I'm not even sure if they cover everything at CCNP level nowadays, because when the first time I wrote my CCNP exam, this was a track of its own. I wrote certification on this. So I'm still saying this is just like the tip of the iceberg. We just want to get to know some things about it. And this is the first time I'm even teaching this particular chapter. I think I mentioned it last week. That's why I don't have a video recording on this. Because I've been cracking my brain for a long time. How do I teach this chapter and do justice within just one chapter? So let's see what we can grab before we finish, just to wrap up this. So this is supposed to be, we talked about on this last week, where I talked about the low latency queue, and we talked about the class base, and then how the router handles packets in general. So today we want to talk about the QoS models. Model is more or less like different ways of implementing QoS. Different way of implementing QoS, which is intertwined with the queuing algorithm. So look at it, selecting an appropriate QoS policy model. There are three models for implementing QoS. There are three models. QoS is implemented in a network using either IntelServe or DiffServe. What's the big deal? What's the difference between the two? This one is not recommended. It's old school, and I'll tell you why. So what is that IntelServe? IntelServe provides the highest guarantee of QoS. Now watch out. Look at the problem with it. It is very resource intensive and not scalable. Very resource intensive and not scalable. So what does that mean? If you decide to go for IntelServe, you're going to put a lot of pressure on your devices. And I'll tell you the difference between the two in summary. The DiffServe is less resource intensive and more scalable. That is why it is recommended. IntelServe and DiffServe are sometimes co-deployed in network QoS implementation. They're very rare, but they said it's possible. So why did we not say there are three models for implementing QoS, and they mention only two? The first model is best effort model, which is by default on your router or on your devices, best effort. It is not an implementation per se. It is just to let you know that the router will try to do its best when you did not even configure QoS to manage the traffic, to manage the queue. And most of the time, you don't even need to do anything as far as regard to quality of service if you don't have congestion on your network. Don't forget, this chapter is basically talking about the context, or let me say it is in the context of a network with serious congestion. If you have a road on your street that is not congested, why should the government dualize it? But the government will only think about dualizing when they notice that the traffic is becoming very high. Or why should the government give you road worker that will be controlling traffic if the road is not congested? So these are all like a form of quality of service. So you trying to manage the traffic, because you cannot have, for some environment, you can't have enough resources on your router, enough bandwidth. The best thing you can do is to manage the traffic. Or let me say it's difficult to have more. So you need to understand that. So it is only when there is congestion that we may be in need of this. If there are no congestion, we don't really need quality loss service. And don't forget, I told you last week, my best, or let me say my preference when it comes to bandwidth management, it's my preferred device is MikroTik, because the configuration is very easy and straightforward. But you need to know that you can also do this on the Cisco router also. So best effort model is not an implementation as QoS is not explicitly configured. So it is in use, or you can use it when QoS is not required. When you don't need quality of service, just leave the router to do what you need to, you can do best. That is the way best effort model works. Then the next one is integrated services. That's the way they shorten this INTSER. Now watch out with this now. This is one that they said is resource intensive. It provides very high QoS to packet with guaranteed delivery. That is one of the reasons why it is resource intensive. It is greedy with resources. How and why? Let me give you an example. I think we should have it on. Okay, let me just draw something and explain it here first. Let me give you an example why it is greedy. If you have 10 routers on the way to destination and you decide to set up integrated service, you are kind of reserving bandwidth all the way from source to destination. That is the way this one works. You don't care about other packets. It will reserve resources for, let's say, data traffic from source to destination. It doesn't bloody care about other people on the road. It's like when the president are passing, or vice president, or most of these lawmakers, the road must be cleared. Even if they will cause congestion for the rest of us, they don't care. And the right way to even put it again is bandwidth must be reserved. And then the drawback with this integrated service, even when that bandwidth is not in use by that data traffic, it is already reserved. And that doesn't make sense. So it's like you have 100 gig on your network from source to destination, and you decided to reserve 20 gig for a particular data traffic. So whether that traffic is available or not, that 20 gig is just sitting there somewhere wasting away. The bandwidth that can be reserved. So look at that's why they say it is resource intensive. But the advantage of this is it provides high guarantee, bandwidth guarantee from source to destination. It defines a signaling process for application to signal to the network that they require special QoS for the period, and that bandwidth should be reserved. That's the way it's implemented. Integrated service can severely limit the scalability of a network because you are reserving bandwidth. It's the only one that is chopping everything. And when you talk about scalability, it's ability to grow, ability to factor in other applications, different scenario, different context. And that's one of the reasons why this is not recommended. Then you have the third one, which is DiffServ, which is differentiated services. It provides high scalability and flexibility in implementing QoS. Like this 20 gig we reserve now for this guy. If the data traffic for that, let's say we've decided to leave that 20 gig for voice from source to destination, even though this one is not implemented from source to destination. If voice is not available at any point in time, we can make use of that 20 gig. The moment voice shows up like this, that 20 gig will be cut off from other people and be given to voice. So it is flexible. This thing will be like this. So it is flexible. Okay. So it provides high scalability and flexibility in implementing QoS. Network devices recognize traffic classes. Take note of that, traffic classes, and provide different levels of QoS to different traffic classes. We can define different way of filtering different traffic. We mentioned that in the last class, just that we didn't call it diff services. So it is your job as the administrator to decide how your devices will treat the traffic, different traffic, how they will be queued, who goes first, who goes next, the bandwidth that will be given, and so on and so forth. It is your job. But unfortunately, that we're not going to have, there's no lab in this particular chapter. I'm not going to be able to configure anything. I hope I'm communicating, please. Am I communicating, please?
Yes, sir.
Okay, good. You know, I pass message across better when there are labs, because I will explain it to you and say, let's see it at work. But unfortunately, this particular chapter, there is no lab for us. But then you need to be aware of that. So you just have to enjoy and listen to the story. Okay, so still talking about the best effort. The basic design of the internet is best effort packet delivery and provides no guarantee. The best effort model treats all network packets in the same way. So an emergency voice message is treated the same way that a digital photograph attached to an email is treated. So what are the benefit and the drawback of best effort? So the benefit, the model is the most scalable. Just leave your device on the network and trust it to do the right thing. Scalability is only limited by available bandwidth, in which all traffic is equally affected. Just pray you have enough bandwidth and you don't have too much congestion. No special QoS mechanism are required. If you don't know about QoS, and as long as you don't have too much traffic, you don't have a problem. And it is the easiest and the quickest model to deploy. But what are the drawbacks? Look at number one here. There are no guarantees of delivery if you have congestion. If you have congestion. Packets will arrive whenever they can and in any order possible if they arrive at all, if you have congestion. No packets have preferential treatment if you have congestion. They should have added that. If you have congestion. Critical data is treated the same as casual email is treated. Just like I mentioned the example of president. You can imagine you are driving on the road. You enter Odo. President is also driving on the road. He enters Odo. If they want to clear the road and give access to some people faster than the others, if it is best effort, they don't care whether you are the president or you are just a civilian or a military person. Best effort, first in, first out. That's the most especially the way it works. You came in first, you go out first. There's no preferential treatment. And that may not be the thing we want on a network that is congested, on a network that has a high-end traffic. It may not be that what you want. You may want to be able to say, no, president doesn't travel every time. In case you see the president coming, prioritize the president. Queue in the president. Even if there are other people on the queue, move them out of the queue, put the president first, and then other people can follow. Best efforts model does not care about this. It doesn't handle the traffic this way. So that is the way it works. For integrated service, I've explained it. You reserve bandwidth from source to destination. That is what is called end-to-end bandwidth delivery or bandwidth guarantee from end to end. So why is there a problem with this? It chops all your resources. It doesn't matter the numbers on the road to destination. All of them must reserve that bandwidth. And the application will hit the bandwidth from source to destination. They don't care. They chop the resources. So this is not a good practice. I think it was back in those days they used this particular technology. So what most people use nowadays is this integrated service. So they use this majorly for voice back in those days. So I don't want to waste time on this. So they use this majorly for voice. Excuse me. Sorry, I think I caught code. So they use this one majorly for voice back in those days. But because of the disadvantages, because it chops a lot of resources, it is no longer recommended. So what do people really use now? It is differentiated service. Differentiated service is very flexible. You give out bandwidth. If it's not in use, like that application, excuse me, then you use it. When the application is in need of it, then it's given back to you. That's the way diff services work. So the differentiated services QoS model specifies a simple and scalable mechanism for classifying and managing network traffic. It is not an end-to-end QoS strategy. Take note of that. Unlike the other one, the integrated services, because it cannot enforce end-to-end guarantees. It is not about hand-to-hand. It is about as you are moving to the next router, they will check, how are we supposed to treat you? What do we give to you? What's the policy applied to you? Router to router. Host hold traffic to a router, which classify the flow into aggregates, classes, that is classes, we call it classification, and provides the appropriate QoS policy for the classes. You are going to classify the traffic in the order of importance or preference to you. You classify the traffic. And the beauty of this particular one I'm talking about, I may not even classify the traffic based on protocol. I can classify the traffic based on where they're coming from. I can see any traffic coming from admin network. It's very important to me because VCL is there, Bosal is there, all these people are there. When you see traffic coming from this IP address, doesn't matter what you have on the queue, I need these people to move first and give these people this particular bandwidth. We can make that happen with differentiated services. So we classify. So we can classify based on protocol, based on IP address. We can classify based on different things. White man, black woman. We can classify anyhow you will want to classify. And the beauty of that classification is after we are done classifying, we can now apply our policies to that classification. Depending on how we want to treat, we can classify based on age. For instance, I'm just using all those things as analogy, as an example. Okay, if you see a traffic that is within, let's say, 18 years or 20 years, all of those kind of different ways is flexible. So it enforces and applies QoS mechanism on a hub by hub basis. That's what I've told you before. It's not about from end to source, hub by hub. Hub simply means router by router. Uniformly applying global meaning to each traffic class to provide both flexibility and scalability. So if I have 10 routers on the way to destination, how we have to define the way I want those traffics to be treated as they are traveling from source to destination, router by router. It's not about hand to hand. Router by router. I will have to define how the traffic will be treated. These services divide network traffic into classes based on business requirement. That's what I just explained. Each of the classes can then be assigned a different level of service. As the packet traverses a network, each of the network devices identify the packet class and services the packet according to that class based on our policy. It is possible to choose many levels of service with this service. I can do. It's like you want to apply policies. You can do and undo whatever you want to do with all those traffic that you've classified. It's up to you. It's up to you. So it gives you power on the network. Quality of service make you a superman on the network. If you know it very well, you become a superman. Because you are in charge. It's like chief of staff to the president. You decide who sees the president, who doesn't see the president, which file is treated, which file is not treated, who goes out, all kinds of policies. And I'm not talking about security now. I'm just talking about traffic flow. You control the traffic flow. You control the queue. You control the bandwidth given with quality of service. So you become a superman. So what is the benefit? It is highly scalable. It provides different level of qualities. What about the drawback? No absolute. It's not like the first one. Absolute guarantee of service quality. But we can still make that happen if we want. And this is the major drawback. It requires a set of complex mechanisms to work in concert throughout the network. If you don't know what you are doing with quality of service, you can't implement it from router to another router to another router without running into trouble. You must be an expert at this. You must know what you are doing. That's the major drawback. And that's why I fell in love with modern day devices like MikroTik. They simplify this is for you. Once you understand the concept, you just go to your command line, your GUI, you activate, you do what you want to do from there. You just simple and straightforward. But if you don't understand the concept, you've never been taught about the technology, you may not know how to handle. You may not, even when you get the GUI device, you may not know what to do, how to make this happen. So it gives you a level of flexibility, and you have power to decide on the network. And don't forget, this is not about you blocking somebody or not to go or to go. No. QoS doesn't give you, yeah, we can block. We can block from QoS. We can say if a traffic is stopping, so bandwidth, it should drop and all of that. But then it's not like when you are doing security stuff where you filter some website and all of that, even though it's not far, they are not far from them. They can coexist and they are not far from themselves. But the main job of QoS is for you to manage the traffic, quality of service on the network. Is for you to manage the traffic. So implementation, we've talked about some of those things that in the last class, where you have the weighted fair queue, class-based fair queue, and low latency fair queue. It's just the same thing we're talking about. Weighted fair, we can implement it. I talked about it in the last video. You can listen to that in the last video. Class-based, you are also explain it. Low latency queue, I also explained this. This is the one we use for voice majorly. But there is one I didn't talk about, and I was trying to remember it in that class. When you want to avoid packet loss, and I think I remember telling you guys that you don't allow your router or your devices to begin to drop packet because of congestion. Because even though you have quality of service in place, if the congestion is too much, there's a threshold in the buffer of that device. If it gets to threshold and the packets are beginning to get to that threshold, it begins to drop randomly. So what do you do in order to affect to stop this? You don't want the router to just drop randomly. You need to let the router know that I don't want you to drop randomly, but I need you to drop lower priority packet before congestion occurs. Don't even allow that congestion to take place. So once it's getting threshold, who's going to set the threshold? You are the one that will set the threshold. You can say, okay, once you're getting to 80% of my buffer, begin to drop lower priority packets. Because of necessity, the router is going to drop. Once the buffer gets filled up, there's no place to put packets again, and there's no place to queue again. It's like when you're queuing and entering an office. Once the place is filled up, nobody can enter again. So as you are getting to the router begins to drop. It begins to drop. It will not even allow the buffer to get filled up completely before it begins to drop. So you don't want the router to do that. You got to get involved and tell the router, I know at the point you may end up getting to this level, and in case you get there, drop lower priority packet. How will the router knows the packet that are of lower priority? You will be the one to determine and set we call it market. You will be the one to determine and tell the router any packet coming from, let's say, students' VLAN or students' subnet. Those ones are low priority packets. It's not compulsory. I don't have. I'm not. If they don't go, and it's not. I don't lose my sleep. You can drop those ones. But if there is opportunity, allow them to go. You will be the one to define all of these things. And these are some of the things I was trying to tell you. The chapter did not do justice to this topic. As a matter of fact, if they want to do justice to this topic, we're going to have nothing less than maybe 5 or 6 chapters. But they still want you to have an idea of what we can do. So most of the time, when we are done configuring this, most of the time we put this together, class-based and LLQ, we end up having this particular configuration to avoid a packet loss, or avoid high priority packet loss. So we let the router know, do what we call weighted random early detection, meaning what? Start dropping lower priority packets before congestion occurs. Once you set this, you go to sleep. And also, you need to understand those packets that are of lower priority, if they are dropped, what happens to them later? Don't forget your TCP. Retransmission takes place if those packets are based on TCP. But if those packets are based on UDP, they are on their own, no retransmission. And most of the time, most of the packets are always based on TCP. So we can be assured of a level of retransmission much, much later. So we are going to rely on TCP to retransmit packets. So we don't have high blood pressure because packets are dropped and they are low priority packet. So what the people will just be experiencing on the network, they will say, this thing is slow. Those people that have lower priority packet being dropped. Why the other people on the network say, the network is very fast now. There's no problem with the network. Everything is going on well now. Who is doing the magic? The administrator that is managing the quality of service on the network. If the administrator does not know what to do, everything is going to be a chaos. Any question, guys? That's just the summary of this thing. So the configuration, we are not going to do configurations. So any other thing here is just long story. So I still have a few slides to talk about, then that will be all. Any question? Are we good? Am I communicating? So I've just summarized most of the slides that are left, so that I will still walk through them small. Okay, good. So different tools we use when we're doing the QoS. Of course, I've mentioned that already. We classify, we mark. The main reason why we mark is for us to tell the router how we prioritize or the kind of priority we place on that packet. And we can mark at layer 2 and we can mark at layer 3. Even when we do the marking, we can still do orders of importance. What I mean by that is we can say, okay, this packet is a priority packet. It's a priority packet. Now I have another packet that is also a priority packet. I have another packet that's also a priority packet. I can now have order of priority. I can have low priority, medium priority, high priority. So even though we are saying it's a priority packet, I can still put them in order. I can also, okay, I can still have another and say, okay, even though this guy is high priority, what if you need to start dropping? Between the low and high priority, which one do I want you to drop first? I can decide to say a particular packet that is of low priority because of how important it is to me. When it comes to the issue of dropping, I don't want it to be dropped. But when it comes to the issue of queuing, I want you to go first. The thing is it's plenty, so many things inside of it. It is low priority, but I don't want it to be dropped. But when it comes to queue, you can queue it later. But when it comes to dropping, I don't want it to be dropped. So I can make all kinds of decisions when it comes to marking and deciding on how the packet will be treated. So first of all, we classify our traffic, and then we can mark those packets. And then we have congestion avoidance tool. The major one is this one that I've talked about, where we don't want congestion to take place. But what if congestion take place, we'll let the router know how to trace those packets. And there are other tools that can also, sorry, this is congestion avoidance rather. And then we have other tools, this is congestion management tools, which are tools to help us to manage the traffic in the first place before we start having congestion. And that is where you have all this your class-based weighted fair queue and low latency queue. These are major tools that we. And you know the funniest thing with this particular topic, the story plenty, not in this chapter alone. I'm talking of even in the curriculum. But the configuration is very simple. Once you understand the configuration, I mean the concept very well, and you enter into your router, you are good to go. To implement this, very simple. At command line. So you cannot imagine at GUI environment how simple these things will be. When even at command line, if you understand the concept, you'll be able to implement it without stress. So I can't go beyond that. So this is what they are saying. Look at it here. When you're classifying and marking, you classify the data, you mark them. Look at the marking here. Some are marked yellow, some are marked red, some are marked blue. After we have classified, so what are we going to do? Later, we can now tell the router how to deal with the blue packets that are marked by blue, the one that are marked brown, the one that are marked gray, the one that are marked yellow. We tell the router how to deal with them. Deal with them in what sense? We can police. Most of the time, when you hear us talk about police, we're giving bandwidth to the data. We can talk about how it's going to queue, because what we are doing right now is about policing, it's about dropping, it's about queuing. We police, we can drop, we can queue. So how do I treat you when it comes to queuing? How do I treat you when it comes to dropping? How do I treat this packet when it comes to policing? Policing is like giving bandwidth to that traffic. And now, of course, scheduling and shaping when you are going out of the router. This is for ingress and this is for egress. So all the summary of this QoS, this is all it is, everything we're going to be, you are going to do in QoS when you go to, if you go to advanced level, you do classification and marking by configuration, you set up your congestion avoidance, and you set up your congestion management. This is not that will take a lot of work from you. So you're basically telling the router how to treat your traffic. Different ways, different things to do. You are telling the router what to do. So it's not small work, but it's very easy to set up if you understand the topic very well. So classification and marking again. Before the packet can have a QoS policy applied to it, before we can apply any policy, the packet has to be classified. Who does the classification? You. What is the classification all about? You just say, okay, this particular packet is classified as, you name it. Let's say ProSpark. So what do you want the router to do with that packet that is classified as ProSpark? Later on, you can go apply a policy and tell the router, when you see any packet named ProSpark, this is how you treat the packet. And by the time we call it ProSpark, we can mark it. Let's say we mark it gray. So the router knows that if I see any packet that is gray, that is ProSpark. This is how I'm going to treat it. That is what the classification and marking is all about. So classification determines the class of traffic to which packet or frame belong. Only after traffic is marked, take note of that, I will classify, I will mark. Only after I have classified and marked, then I can apply policy to it. I will classify, I will mark. After that, then I can apply policy to it. And there are different ways to classify. We can classify and mark at layer 2, especially marking. We can mark at layer 3. We can use our we can mark interface. We can mark access list. We can mark by class mask. So many ways to do this. We can mark all the way to level 7 from level 4, application layer. And this is the technology used back in those days before we got modern day firewall that can do all of these things for you. Modern day firewall can do all of these things for you, like Cisco Firepower can do all of these things I'm talking about for you. We can do QoS for you. You can manage the network traffic. You can deny so many things can do. But this is just on the router. So we're assuming you don't even have those firewall. How can you still make this happen? And don't let me forget to tell you something. If you don't know QoS very well and you implement QoS on your router, it's going to slow down that router. So other job that the router is supposed to be doing on the network, routing, doing that, and all of that, is going to be it's going to affect the production of the router. It's going to affect the performance of the router. That's the right word to use. So that is why nowadays, most of the things we are talking about, they've shifted that responsibility to the firewall. Firewall can do most of these things we are talking about. And let me tell you another thing. For you people that are doing CCNA, we have touched a level of security stuff on network security, quality of service. The day you make up your mind to do training on firewall, network security, using any firewall, you will discover that this is just a walkover. Because most of the firewall you have are GUI. Once you know the what do you call it, the policies you want to implement, once you understand what you are trying to do, that's it. You just go there, activate, click something, okay, that you are good to go. It is very easy. Once you understand what's right. I think this should be the last. Trust boundary. Traffic should be classified and marked as close to its source as technically and administratively feasible. This defines the trust boundary. Summary of this is this. If I want to mark and classify, where do I want to apply my policy? It will not make sense for my packet to have passed through 3, 4, 5, 6, 7, 8, 9, 10 routers before I now apply a policy. It is good to apply the policy as close as possible to the source of that traffic, depending on the kind of policy I want to set. That's the ways where I can summarize this for you people. If we are doing QoS in detail, I'll be able to go into other details, configuration, and demonstrate and show you this. So trust boundary is more or less like, okay, from here to here, we may not even have any policy applied, but once it gets to this place, we apply the policy and decision must be made. But it is good to make it as close as possible to the source. That is the way QoS operates. More of this in CCNP class. We've talked about congestion avoidance. This is a repetition. You make sure that you implement your reg in order to prioritize the traffic that will be dropped and not dropped. Shipping and policing, it's all about the bandwidth that will be given to the traffic. One is very nice, the other one is very cruel. What's the difference between the two? The one that is nice can even knock off the traffic. It will not allow you to burst. I think which of them does that? I think it's policing. Policing will not allow you to burst. What do I mean by that? If you have given 20 Mbps to a traffic and you can burst, you can move to 25 Mbps if the traffic, the bandwidth is available and used, you can use 30. Policing will nicely bring you back to your level. You're not supposed to go beyond 20. But shaping will never allow you to burst. It will never allow you to burst. It won't allow you to burst. I think one can also be applied to inbound traffic. The other one can be applied to outbound traffic. Which of the two? Shaping is an outbound concept. Look at shaping there. While policing is an inbound traffic on an interface. So the two of them is all about the bandwidth that will be allocated to the traffic. And it is part of our quality of service. And this is the one that most people use in Microtik. They allocate bandwidth to users. They hardly do this queuing stuff, even though Microtik can also do queue. But this is under Cisco stuff. You need to understand that. So still talking about policing, it's applied to inbound traffic. It can allow you to burst. Look at the busting I've talked about here. The shaping will not allow you to burst. Shaping will allow you to burst. So if you want to create QoS, what are the things the policy you need to follow? Even though it doesn't make sense telling us the guidelines. When you didn't teach us the configuration, no lab. But let's just listen to them. QoS policy must consider the full path from source to destination. A few guidelines that help ensure the best experience for end users includes the following. Enable queuing at every device in the path between source and destination. Classify and mark traffic as close to the source as possible. Shape and police traffic flow as close to their source as possible. So it's all about queuing, classification and marking, shaping and policing, and of course, congestion avoidance. That is just the end of QoS. So if you want to learn more about QoS, if you are curious to